Welcome back to All This Math. This is Professor Parker. You see me, I was just checking out these three problems I got up here. And shout out to Lincoln University. You know what I'm saying? Not the one in Oklahoma, but, respect to the one in Oklahoma, but this is the Lincoln University that's in Pennsylvania, in Lincoln, Pennsylvania, about an hour outside of Philly. And they also have a graduate center in downtown Philly near 30th Street Station. Shout out to them. That's where I got my master's from. Graduated such greats as Kwame Nkrumah, Osajifo Kwame Nkrumah, the first leader of an independent Ghana in 1957. Also graduated Nnamdi Azikiwe prior to Kwame Nkrumah, who was a revolutionary leader in Nigeria, with the part of the Zikist movement, a journalist turned politician. A lot of important figures graduated from Lincoln University. Definitely do your research. Do your research on Lincoln University and the type of individuals that it bestowed degrees upon, or people that earn degrees from Lincoln University. All right, let's check this out. So we got three examples up here. We are factoring, right? This kind of gives it away. Dots, the dots method means difference of two squares. But I'm gonna tell you, you can't even get, in these examples, you can't get to the dots method unless you factor first. So you got to get in the habit. I'm just going to say this, man. Like sometimes you can use the dots method first if you got a binomial and both of your terms are perfect squares. You got a minus sign in between. You might want to do that. But notice all of these three examples. None of these are perfect squares. 20 is not, 45 is not, 3 is not, 75 is not, 24 is not, 54 is not, x is not, x to the third is not. You know what I'm saying? A squared is and n squared is, but everything got to be a perfect square in order to use the dots method. So you can't use the dots method. But in this situation, you got to find a GCF and pull that GCF out. Once you pull the GCF out, that's like the key. You unlocking it. You know what I'm saying? You unlocking it, and then you can do some other type of factoring. So look at number one, 28 squared minus 45, right? That's got a GCF. Look at this 20 and look at this 45. What's the greatest common factor between 20 and 45? 20 and 45, 20 and 45. All right, it's 5. It's 5. All right, it's not 10. Because 10 is not a factor of 45, because 45 ends in 5. So you got to know your factors. You got to know your factors and your multiples. Factors, multiples, factors, multiples. You got to know them. You just got to know that. That goes right along with knowing your multiplication facts. All right? If you know your multiplication facts, then you'll know your factors, because you'll be able to just organize the multiplication facts and assign them to certain numbers. All right? So the GCF is 5. A is not part of the GCF because A is not common. The C in GCF stands for common. 45 don't have no A. So watch this, right? This was about to happen. Like I told you, it's going like it's like an unlock. It's like a key. It's going to unlock the expression, so you're going to be able to do some more factoring. Because remember, when we factor completely. We don't factor incompletely. We factor completely. So we pull the 5 out of this and the 5 out of that. Then we're going to have 5 and then parentheses. And then what goes in the parentheses? The quotient between this and the GCF. This and the GCF. This and the GCF. So 20 divided by 5 is 4. Then you just put that a squared next to it. So we got 4a squared. Then you bring your minus sign over, right? You do 45 divided by 5. That's 9. Take a look at that right there. Look at that. Beautiful. This binomial. It's a difference of two squares. So now we got what we want. So now notice this though, right? If you didn't take the GCF out, you wouldn't be able to factor it completely, right? You got to take sometimes you got to take the GCF out first, and then you can keep factoring, right? You got to know how to take that GCF out though. So look, this is what's going to happen. You're going to put your equal sign. You're going to bring the 5 down, right? Now, this is a difference of two squares because that's a minus sign. That's the difference part. This is two terms. That's the 2 part. This is a perfect square. 4a squared is perfect. 9 is perfect, right? So they perfect squares, all right? So how you set it up is like this. 2 binomials next to each other. Take the square roots of each term. The square root of 4 is 2. The square root of a squared is a. So the square root of 4a squared is 2a. Again, the square root of 4a squared is 2a. So you put a 2a right here. You put another 2a right here. You take the square root of 9, which is 3. I know that's a minus sign right there, but we're going to treat it like it's positive. You're going to take the square root of 9, which is 3. Put a 3 right here and a 3 right here. Put a plus sign in one of them, put a minus sign in the other. And this is done. This is completely factored. 5 times the quantity 2a plus 3 times the quantity 2a minus 3. On to number 2. Number 2, again, look for a GCF. Pull the GCF out. What's the GCF of 3 and 75? It's 3. Then you divide each of those terms by 3. 3n squared divided by 3 is just n squared. You know why? Because 3 divided by 3 is 1. 3 divided by 3 is 1, and 1n squared is just n squared. You don't got to write the 1 when it's a coefficient. Just like you don't got to write the 1 when it's an exponent. You don't got to write the 1 when it's a denominator, unless you need to show a fraction. That's up to you, though, right? Then you do negative 75 divided by 3 is negative 25. Now watch this. Isn't that a difference of 2 squares? Dots method. Let's go. Dots method. All right, same thing we did in number 1. Bring that 3 down. Write your 2 binomials. Square root of n squared. Put an n right here, put an n right here. Square root of 25. Put a 5 right here, put a 5 right there. Make one a plus, make one a minus. Doesn't matter where I put the plus and the minus sign. No, it don't. If you want to always put the plus sign in the first parentheses, go ahead and do that. If you want to always put the minus sign in the first parentheses, go ahead and do that. You just got to have one of each. All right, now let's look at this one. Let's look at this one. All right, what's the GCF? 24 and 54. I know X is going to be part of my GCF because they got X's in common. And you always take the variable with the smallest exponent that they got in common. X to the third, X to the first. No exponent written means it's X to the first. So X is part of the GCF. 24 and 54. My greatest common factor is 6. 6, not 2, is 6, right? 6 goes into this 4 times, 6 goes into this 9 times. Watch what's about to happen. My GCF is 6x. Why is my GCF 6x? Because 6 is the common factor between 24 and 54. 24 and 54. Why is x part of my GCF? Because x is the variable they have in common, but you always take the variable with the smaller exponent. The smaller exponent. This has an exponent 3. This has an exponent 1. 1 is less than 3. So you take x, because x has the smaller exponent. X to the first. Then you put your parentheses. One set of parentheses with a GCF. You divide this by a GCF. You divide that by a GCF. Put them answers inside the parentheses. 24 divided by 6 is 4. X cubed divided by x is x squared. 54 divided by 6 is 9. X divided by x is 1. So it's just 9 by itself because it would be 9 times 1, which is 9. Bring the minus sign, put it right there. This is a difference of 2 squares, just like this was a difference of 2 squares. And this was a difference of 2 squares. This is basically the same thing as this, just with a different variable. Different variable. Now, let's finish it. So bring that 6x down. Put your 2 binomials. Square root, 2x. 2x. Square root, 3. 3. Make 1 plus, 1 minus. Look what I did. I switched it up on you. Put the plus sign first this time. I could do that. You could do that. Whatever you want. All right? This is the final answer. Boom, that's that. Now we have factored completely. We have factored completely. So we got, we factored completely. All right? But definitely get you some practice because sometimes you're going to have to pull the GCF out and then use the dots method. Difference of 2 squares. Difference of 2 squares. All right? So keep that in mind. You know what I'm saying? Like, this gets easy. You know, it gets easy. Like, once you pick up the pattern, it's all about patterns. That's all algebra is. It's all about patterns. Once you pick up the pattern, then it's easy. Your muscle memory going to kick in. It's not going to be easy at first. It's not. You got to learn it. Somebody might have to explain it to you. But then once you get the pattern, then it's just, you know, it's like riding a bike. You know, it is what it is. You know, so yeah, go get you some practice, get some homework problems, ask your teacher, ask your professor, ask whoever. But go get some practice so you can master this. All right? And I'll see you in the next video. Peace.